In this video, I'm going to present about atmosphere. So, atmosphere is a set of layer of gases surrounding a planet or a material body that is held in place by gravity. So here, the gravity plays a major role in holding the atmosphere or the gases layer of gases. Say this is Earth, and it has a layer of gases which is surrounded on the Earth's surface. These atmospheric gases are held together towards the Earth because of the gravitational force which the Earth has. And what are the major constituents of this atmosphere? So major constituents are gases like nitrogen, which is the major component, which is 78 percentage, and oxygen, which is about 21 percentage, and argon 0.93 percentage, carbon dioxide, which is about 0.03 percentage. Why do you have a major component as a nitrogen? Throughout the geological period, so the nitrogen is not much reactive in its gaseous form, and with solar radiation, if solar radiation also doesn't much affect this nitrogen, so it's very stable in the gaseous form in the atmosphere. So slowly it accumulated and it formed the major component in the atmospheric gases, whereas oxygen is not much stable. It gets affected by the solar radiation also. So that's why the constituent of oxygen is 21 percentage, and the major component is nitrogen, which is in gaseous form. Whereas nitrogen, when we see it is in a crystal form, it is not that much stable, it's much reactive. Whereas in the earth crust, which oxygen is the major component along with silicon. So but in the atmosphere, the nitrogen is the major component. Apart from that, we have other gases like neon, we have, which is 0.0018 percentage, and helium, which is 0.0085 percentage, and we have other ozone, hydrogen, krypton, xenon, and methane. So these are the major gases. These are some other trace elements. So especially this krypton, xenon, methane, and these are in trace amounts, and these are in minor quantities. Apart from that, we also have water vapor, which is about 0 to 5% of atmospheric volume. And this water vapor is when it comes, this water vapor, when this water vapor is this is very transparent to the incoming solar radiation. So this incoming solar radiation comes towards the earth's surface without any hurdles. But when this water vapor, when this radiation, when it is going back as a long wave radiation, it is not that transparent, it's less transparent, so that the heat is trapped within this layer, so that it helps in warming the earth's surface. Apart from that, we know that nitrogen is very important. It acts as a diluent also, and generally it's chemically inactive also. Carbon dioxide is very important for photosynthesis, and it also absorbs energy and radiation. And we know that oxygen is very important for breathing, and it's very important for combustion also. So apart from that, we have particulate matter. These are solid particles which are in suspension in the atmosphere. It's suspending it's in suspension. So in the atmosphere, it's just floating like that, because the size of this particle is very less. So that's why it's capable of suspending in the atmosphere. So what are these particulate matter? So these particulate matter are like dust particles, salt particles, pollen, smoke, soot, volcanic ashes, and these are some particles which are in suspension in the atmosphere. So they are in suspension in the atmosphere, and these particulate matter is responsible for the scattering of light. So because of the scattering of light, we have different effects, like during dawn and dusk, we have the reddish color of the sky and the blue color of the sky. And these salt particles, these dust particles, this particulate matter forms the hygroscopic nuclei, and thus help in the formation of the water drops and clouds. So this helps in the precipitation and condensation. So in this cycle also, this particulate matter helps. So Next, we are going to see the structure of the atmosphere on the basis of the temperature and air pressure. We have 4 layers. We have classified the atmospheric structure into 4 layers. These major layers are troposphere, stratosphere, mesosphere, thermosphere, and this thermosphere can be further classified into ionosphere and exosphere. So let's see in this diagram. So here we can see this is the troposphere, which is near to the Earth's surface, so which is about 6 to 20 kilometer. Then we have stratosphere. Above troposphere we have stratosphere, and above stratosphere we have mesosphere, and then we have thermosphere, and above thermosphere we have the outermost layer, which is also called exosphere. So here in this image we can see what's happening, how temperature varies in each layer. So troposphere, the temperature slowly decreases. Here we can see it's 20 degrees Celsius. It slowly decreases to minus 80 degrees Celsius. And why it is? Because the lapse rate, normal lapse rate, we will say it as 6.5 degrees Celsius. So the normal with, so it is decreasing 6.5 degrees Celsius. It's decreasing slowly per kilometer, and it is decreasing like this. And further, this here the temperature is increasing in the stratosphere. So why temperature is increasing the stratosphere? Because here, so in this region, so this here ozone is there. So majority of the ozone traps the ultraviolet radiation. So because of the slight heating of those atmospheric layer is taking place, that's why here temperature is slightly increasing here. So in this layer it is decreasing less, then it is increasing slowly, then again it is decreasing in mesosphere. That's how the temperature varies in the atmosphere. So let's study in detail about each layer. So we know that in troposphere, these clouds formation, raining, all these things happens in this troposphere. In stratosphere, it's because here there is not much disturbance, so that here planes and aeroplanes and all jets and all balloon weathers can be seen. In this layer, these jet planes and all goes in this layer, stratosphere, because here not much, here it is not much, there is no obstacle or any disturbances in this stratosphere. In mesosphere we have any rocket launches and all, here takes place in this mesospheric layer. So it's about 100, and especially above 100 kilometers from the Earth's surface. In these layers rocket launches and all is taking place. So first let's see troposphere. So we know that troposphere is the lowermost layer, and upper limit of troposphere is called. So the upper limit of this troposphere is called tropopause. So an average height is up to 6 km in polar regions, up to 16 km in equator. But it is not stable. This troposphere height is not stable in all the seasons. It varies with the season. So what's the reason behind the changes in the average height or the altitude of this troposphere? The reason behind is the surface temperature and the moist air or the moist condition, the water vapor. These two things plays a major role in determining the altitude of this troposphere. So because if moist air, what happens if moistness of the air is more or humidity of the air is more, then it lowers the lapse rate. So it lowers the lapse rate. Say if moist air, the lapse rate is just 5 degrees Celsius per kilometer. Otherwise normal average lapse rate, as I said, it is 6.5 degrees Celsius. But moist air, in the moist air, the lapse rate reduces to 5 degrees Celsius per kilometer. In equatorial region, we know that here it's a equatorial region is a humid region, and here the monsoon seasons, like monsoon seasons, here it's heavy precipitations are there. So because of that, the lapse rate reduces further. So the height of the troposphere increases in this region. Whereas in the polar region, it is a dry region. Because of that, what happens, the height of the troposphere decreases in this region. That's the reason behind the change in the height of a troposphere. in the polar region and equatorial region. So here the moist condition pushes the troposphere upwards, and if dry condition pushes the troposphere downwards. So in this we know that in troposphere all weather phenomena occurs, like precipitation, thunderstorm, lightning. All these weather phenomena occurs in this troposphere region, and temperature falls by 6.5 degrees Celsius per 1000 meter, which is per or 1 kilometer height, and which is a normal lapse rate, as I said earlier. And the height of tropopause varies seasonally, because I know that because of that monsoon condition, whether it's a rainy season or a winter season or a summer season. Depending upon that, the humidity of the air varies and the temperature also varies, because as I said, temperature and water or the humidity plays a major role in determining the height of troposphere. So here we can see that in this is the equatorial region. The height is the height is up to 15 kilometer. It can further increase up to 20 kilometer also, depending upon the season. Whereas in the other, when it moves towards the polar region, the height of the troposphere decreases slowly, because here it's a cold region and it is a dry region, so the tropospheric height decreases slowly. So even in this image, in this graph we also can see in the equatorial region height is more, and the cold region the tropopause height is decreasing. So we can understand that humidity and temperature plays a major role in determining the tropopause height. Then stratosphere. The average height is about 50 km and the upper limit is known as stratopause. In lower stratosphere, the feeble circulation of wind and cirrus clouds are seen, but very important thing is happening in this ozone stratospheric layer, which is ozone. Here the concentration of ozone is more, which is about 15 to 13 kilometers. From these distances we can see a major concentration of ozone, but it is also found up to 80 kilometers. So what does the ozone does in the earth atmosphere? How it is useful to human being? So we know that what ozone is formed. Oxygen molecules reacts with the ionized oxygen and it forms ozone molecules, and it is not stable. So here it absorbs the UV radiation, ultraviolet radiation, which is ozone, which ultraviolet radiation, which is harmful to the human being. So this violet radiation is trapped in because of this ozone layer, which is found on the stratospheric layer, and temperature gradually rises upward and becomes 0 degrees Celsius. The reason behind that is here the ozone layer is there, so the whatever sun radiation is coming, the ultraviolet radiation is trapped in this region. So because of that, it increases the temperature of this stratosphere slowly. So that's how the temperature increases in the stratosphere. Next one is mesosphere. The height is or altitude is about 50 to 80 kilometer. So the upper limit is meso, as we know, and temperature falls again with increasing height. So here again with increasing height, the temperature falls, and at up to 80 kilometer temperature is minus 80 degrees Celsius, and above 80 kilometer the temperature increases further. So the next layer is thermosphere, and here temperature increases rapidly with increasing height, which is up to 1700 degrees Celsius. So here the temperature is very high, but it can't be felt much because the density of the air is very light, because the density is very low here, so which can be felt, but air density is too low, so much temperatures cannot be felt. So even with the normal temperature we can't check the temperature here. Where normal thermometers we can't check the temperatures here, because here gas density is very low. That's why we can't feel the temperature, though the temperature is very high, which is about 1700 degrees Celsius. And it has two layers. One is ionosphere, which is about 80 to 640 kilometer, and the other layer is exosphere. So ionosphere and exosphere. Exosphere, the uppermost layer of the atmosphere is called exosphere. So in this exosphere, what happens? So this the outermost is a space, we call it as a space also. But about, when we say about 100 degree, 100 about 100 kilometer from the earth's surface, we can about so above this region it is also called as space. So space, because here we know that the gaseous density is very less, and it's very dark here. The reason behind that, here there is no scattering of light is taking place because there is no dust particles, and here very light gases are there, and that's why this is dark here. But from the space, when we see any objects, earth can be seen from the space, or any stars, any sun also can be seen from the space. But the space is dark because here the matter is not there. When suppose light, when the light falls on object and is reflected to the eyes of a human being, then only the object is visible to the human being. So here is such, suppose the atmosphere is close, here close, atmospheric particles are close and density is high, there is chances of scattering, but that kind of activity is not taking place. That's the reason here space is dark. And ionosphere is very important layer. Here the particles are in the ionized stage because of the highest temperature, and in this layer these radio waves are reflected back towards the earth. That's how we have radio communication, satellites and all we have, because of this ionosphere only. So the next one is chemical. On the basis of chemical composition, we can classify atmosphere into homosphere and heterosphere. So homosphere, which is up to 90 kilometer, here the various gases are in uniform proportion at different levels. So say nitrogen, oxygen and argon, so the major components which are in uniform proportion. Whereas in heterosphere, which is about to 90 to 10,000 kilometer, vary in physical and chemical properties. In homosphere, we know that these are in uniform proportion, but in this layer it is not in the uniform proportion. It is the proportion is not same in this heterosphere. So heterosphere also can be classified further into, say, molecular nitrogen layer. So molecular nitrogen layer, which is up to 90 to 200 kilometers, and oxygen layer, molecular or atomic oxygen layer, which is about 200 to 1100 kilometers, and 1100 to 3500 kilometers, which is helium layer. Then further atomic hydrogen layer, which is about 3005 kilometer, or outer layer. So which is also, that's how we can classify heterosphere further depending upon the molecules which are there, the major component of the molecules which forms this layer. So in this image we can see here, so this homosphere, so up to this layer, up to say up to 90 kilometers homosphere, and above that it is heterosphere. So homosphere, we know that the component of this nitrogen, oxygen, argon. So here the constituents of these nitrogen, oxygen and argon. So this is uniform here. Okay, it's uniform here. In heterosphere it is not uniform. So in the lower, because the molecular weight is high, because it's classified on the basis of molecular weight. Molecular weight is high, that's why it's close to the earth's surface. Whereas when we go upwards, so it's atomic oxygen and helium, atomic hydrogen. That's how we are classifying them, because here it's not a molecule here, it's a atomic oxygen, so it's in ionized state here. When it goes to a higher altitude, here ionization takes place because the temperature also is very high in this region. So here these particles, hydrogen is a very light particle when we compare it with nitrogen and oxygen. So here, so they just escape the earth's gravity and they can float in the upper atmosphere or outer atmosphere. So that's why they are in the outer surface, and these particles, molecule which has some higher molecular weight, they are close towards the earth's surface. So that's why these homosphere and heterosphere are classified on the basis of chemical composition of different molecules which are there in the atmosphere. So these are all about